From numbers that shouldn't exist to a fact that 1 plus 1 equals 0, here is a list of fascinating mathematical discoveries, starting with...
In math, some numbers feel strange, but this one is on another level. These are numbers that shouldn't exist because no logic, no formula, and no computer could ever produce it. And yet, it does exist. To see why, start with the real number line. Infinite, continuous, unbroken. But hidden inside it is a disturbing fact. Almost every number on this line is impossible to name. Not just difficult, not just unknown, literally impossible to define. But before I tell you about that, let's talk about the ones that we do know about but shouldn't exist. 0. There's no such thing as 0. You either have or you don't. What's the point of saying, I have 0 girlfriend when you don't have one in the first place? Give 6 people $0 and you are giving them nothing. And yet you can say, I gave them $0. But what you gave them did not exist. This is also true about numbers -1 to infinity. There's no point in saying I gave them -$1 because just like 0, what you gave them does not exist. The only difference is that you can say I gave them $1, but they have and can spend $2 with the -1 proving as an addition. This is true to any number with minus as their prefix, and why -1 is bigger than any other number with this prefix. This did not stop mathematicians and scientists alike to find uses for these numbers. 0 tracks when something is absent, just like my empty bank account balance, a score of 0 in a game, or having no items left in stock. 0 is also one of the 2 binary digits that form the foundation of all digital information. While negative numbers are used by banks to show a debt or an overdraft, like an account balance of -50, which indicates a debt or an overdraft of $50. Temperatures below the freezing point are expressed using negative numbers, such as -10 degrees Celsius. This kind of made them very useful, but the fundamental definition of these numbers states them useless. Now back to numbers impossible to name. Think about how we normally describe numbers. We give a formula or a pattern or an algorithm that generates its digits. Pi, e, radical 2, complex but describable. But there exist numbers whose digits contain no pattern, not random, worse, uncomputable. Mathematically, their existence is unavoidable. Cantor proved there are uncountably many real numbers, but only countably many descriptions, formulas, or algorithms. That means there are more numbers than ways to describe them, infinitely more. So most numbers cannot be written, computed, or even defined, not because we lack technology, but because it's logically impossible. And yet they're real. They exist on the number line right between the numbers we can describe. For example, 0.1 to infinity or 5.1 to infinity. It is impossible to name an infinite number just the way you can name a prime or even number. I am not going to talk about the term imaginary numbers simply because it's already in the name, imaginary numbers. It basically explains itself.
Now let's switch gears completely from the imaginary to a question so damn simple that you're definitely about to get it wrong. Because if I ask you what's 1 plus 1, you'll say,
It's 2, right? Wrong. The answer could also be 10, or 1, or 11, or even 0. The truth is, what is 1 plus 1 is one of the simplest questions in the world that is impossible to answer, unless you have one crucial piece of information: context. We've all been trained to assume one thing. When we see this equation, we assume we're in the system we learned in kindergarten, standard arithmetic. In this system, 1 is the symbol for a single unit, 2 is the symbol for the next unit in the sequence, and plus means to add them together. It's a set of rules we all agree on, and in that context, the answer is, of course, 2.
But what if we change the system? What if we ask a computer? If you're a computer, you don't operate in base 10. You operate in base 2, or binary. You only have 2 digits, 0 and 1, off and on. In this system, the number 0 is written as 0. The number 1 is written as 1. But there is no symbol for 2. So just like in our system, when we run out of digits at 9 and have to roll over to 10, 1 10 and 0 ones, binary runs out of digits at 1. To write the number 2, it has to roll over. It becomes 1, 0, meaning 1, 2, and 0, 1s. So when you ask a computer, what is 1 plus 1? The real answer is 10. But what if the 1 isn't a number at all? In almost every programming language, the plus symbol can mean two different things. If you're using numbers, it means add. But if you're using strings, that is, pieces of text, it means stick them together. Programmers call this concatenation. So if you tell the computer to add the text string 1 to the text string 1, it just sticks them together, and your answer is 11.
What about Boolean logic? This is the fundamental true-false logic that powers every single computer chip. In Boolean, 1 means true and 0 means false. In this system, the plus symbol often means the logical operator OR. So the question 1 plus 1 is just a different way of asking, what is true or true? Well, if I ask, is it raining or is the sky blue? If both are true, the whole statement is still just true. So 1 plus 1 equals 1. And this isn't just abstract. Think about the real world. What's 1 drop of water plus 1 drop of water? It's 1 bigger drop of water. 1 cloud plus 1 cloud equals 1 bigger cloud. 1 plus 1 equals 1. Context. But my favorite wrong answer is 0. How on earth can 1 plus 1 equal 0? This is called modular arithmetic. It's the math of cycles, or clocks. Think about a 12-hour clock. If it's 10 o'clock and you add 4 hours, you don't get 14 o'clock. You get 2 o'clock, because when you hit 12, the system wraps around back to 0, or 12. Now, let's imagine a clock with only 2 numbers on it, 0 and 1. This is called modulo 2. We start at 0, we add 1. Now, we add 1 again. 1 plus 1 equals 2. But there is no 2 on this clock. We wrap all the way back around to 0. This system, 1 plus 1 equals 0, isn't just a party trick. It's the basis for the XOR logic gate, which is used in everything from simple calculators to complex data encryption.
So what's the real answer? The answer is all of them, and none of them. You see, a question like 1 plus 1 is meaningless. It's just symbols on a screen. It's like a language without a dictionary. 2 isn't the right answer. 2 is just a convention. It's the result of a system we all silently agreed to use. And that's the real power of mathematics. You can use this against that all-knowing friend you have, and if he is a subscriber or have liked this video, you might want to ask them a simple one right back. What are the rules? If he is a 6-7 kid, don't bother. Did I miss any? What about biology? 1 rabbit plus 1 rabbit equals a lot more rabbits. Okay, bye.